Remains 2 minutes to welcome everybody. Then we can start. Let's wait for 2-3 seconds. Start. Mm, Okay. Hi everyone. So basically, we are all gathered here for today's BRB, that is by Biconomy. Let's wait for some seconds so that we can start further. Okay. So, hi, my dear builders and partners at BRB. I am Diksha, community advocate at Push Protocol. It's a pleasure to welcome all of you to our very first and highly anticipated introductory session for BRB Online. Moreover, I extend a warm and heartily welcome to our special partner for today's event, Biconomy. So, as we all know, BRB is basically Billion Reasons to Build. It is an initiative by Push Protocol in collaboration with best Web3 protocols in the space. So, here we solve some of the hardest problems of Web3 and win $5,000 for each of them. Also, we got a chance, like you got a chance to grab around $55,000 plus bounties plus swags. So let's take a quick look at the agenda for today's session. For today's session, we are having one amazing human with us, and I think he don't need an introduction, but still, welcome Rahat. He's head of DevRel at Biconomy. So let's begin with your introduction. The stage is all yours. Please begin.
Thanks, thank you, everyone at Push for having me on this. It's really cool to be part of BRB and everything that you guys are doing here. So yeah, hi, my name is Rahat, head of developer relations for Biconomy. I've been working kind of like with Biconomy on helping to build better on-chain UX, because the only way we're going to be getting more users into Web3, the only way we'll be able to make better experiences is by improving the user experience, by making onboarding more seamless, and by providing people with ways to achieve different UX experiences that weren't possible before. And we do that via ERC 4337 account abstraction. And that's a little bit of what I'll be talking about today for the workshop.
Yeah, so guys, we are going to have an amazing workshop by Rahat. So let's begin. So yeah.
Awesome. Cool. I will share my screen and we can get started. Cool. So this is an introduction to modules using the Biconomy SDK. So basically, the bounties that we have for BRB are centered kind of around building modules for our smart accounts. So I'm going to be taking you through kind of like a really basic module today. We'll do a demo, we'll run through some code. All of that will be part of this here as well. This is my intro slide. We kind of already did the intro, but really quickly again, head of DevRel Biconomy. I've been a front-end engineer, former founder as well, former hip-hop artist. I've retired. I don't do the hip-hop thing anymore, so I no longer do raps in workshops or anything like that, unfortunately. So yeah, I usually look like one of these two things in the interwebs. Cool. If you need like a primer on account abstraction in general, to be clear, this specific workshop is not going to be an introduction to account abstraction. You can check out this previously recorded workshop here if you need, and this will take you through some of the basic stuff. If you need a review on that, if you need to like understand a little bit about like what account abstraction is, what the full flow is, and how 4337 kind of like fits into the Biconomy SDK. This is not really an introductory workshop. This is more focused on the modules, but I just wanted to make sure that you folks have this additional resource in case you need it. So the Biconomy SDK, what exactly does it do? The Biconomy SDK comes in mixed and matchable packages. There's several different packages that helps you tap into the full flow of account abstraction in 4337. We have the smart account package. That package is going to help you to deploy smart accounts and create user operations. Again, these are terminologies I'm using that was all explained in the previous workshop. You can go back and learn more about it there. Paymaster package. So the Paymaster does one of two things. It can help you sponsor gasless transactions or allow users to pay for gas with ERC20 tokens. And then the bundler package. The bundler is what interacts with our user operations and sends them to what's called an entry point contract on each of the different chains on the EVM network that you can transact on. So the bundler is actually responsible for taking the user operation and actually turning it into a transaction on the EVM. So all in all, we provide like the full stack of account abstraction, everything from smart accounts to the infra side on the Paymaster and bundler, so that if you want to work in account abstraction, we can provide you with everything that you need out of the box. And now one thing that we're kind of introducing, we announced a little about a month and a half or 2 months ago, is the Smart Account Platform. So what is a Smart Account Platform? It extends the capabilities of the Smart Account with what are called modules. And that's going to be our focus for today, building a module. So there are a few different modules that have already been built into the SDK, and I'll just like briefly go over some of them. First is the ECDSA module. So ECDSA is just the signature algorithm that you may be used to for like regular wallets. So regular wallets, like if you go and create a MetaMask wallet, these different types of wallets are also known as EOAs, or externally owned accounts, and they rely on the ECDSA to actually function. For a smart account itself cannot actually initiate a transaction on chain. You need what's called some type of owner or EOA to actually sign on behalf of that smart account. So what this ECDSA module is doing is essentially saying, okay, here is an EOA. Here is a smart account. This EOA is going to sign for all of the transactions for this specific smart account. And you're going to see a demo of this shortly. Multi-chain validation modules. So this is essentially the same thing as the ECDSA module. It's an extension of it, but now instead of just being able to transact on one chain, using a single signature, you can actually transact on multiple chains. So any of the chains that we support, you'd be able to use a single signer across the different chains there. We have examples on how to do this within our docs, and I'll briefly also go through the docs to show you some of the things that you can take a look at there. Session Key Manager module. So the bulk of our workshop today is going to be around session keys. And I'm going to give you some ideas of stuff you can build specifically around the session key side of things. But session keys really give you a really awesome way to unlock Web2-like experiences on-chain. What exactly do I mean by that? The Session Key Manager module enables the use of sessions and session validation modules. So what is a session? A session essentially gives permission for a specific signer or EOA to sign on your behalf. So not specifically like on the ECDSA module, it's like your own EOA that is able to sign on your behalf. But now through the Session Key Manager module, you can give very specific permissions to a dApps EOA to do some signing on your behalf. So what are some things that can be unlocked here? If you even think about like Lens protocol and how some of the different social media apps on Lens work, you only have to sign once, and then all of the other on-chain interactions, you don't have to keep signing, right? Like if you're posting on any of the Lens protocol apps, if you're posting, if you're liking comments, following people, you don't continuously sign. And this is the type of thing that this Session Key Manager module can enable for your dApp. This ability to not have to keep signing to keep doing on-chain interactions. You can unlock a lot of cool experiences with this. Just take a look at like on-chain gaming. On-chain gaming is hard because, like, if you think about it, no one wants to like play a game where you have to sign every single interaction for everything that you do in the game, right? Bring in session key manager module. Now you can have a completely on-chain game with a Web2 experience. So you can actually focus on making the game fun, and still being decentralized and on-chain. Because to be frank, most on-chain games suck. They're not actually fun because you have to like think about all the Web3 stuff. This allows you to abstract away the Web3 stuff from your user, so that they can just focus on having fun, focus on using your app if it's not a game, while still being transacting on-chain. The batch session router module is very similar to the session key manager module. I'll again kind of like point you towards the docs on that, but we won't really focus on it there. It allows you to have multiple different types of sessions batched into one app. So if there's like different types of permissions you want to give to different session keys, that's another thing that you can do as well. So yeah, like I mentioned, today's focus is going to be around session key modules and how you can build your own modules for the validation logic in the session keys. Let's dive into a demo and some code. So I believe I already have this running. Let me just head to my local host. Okay, I do. So I'm going to give you a quick demo first before we dive into the code, just so you can visually see what exactly we're going to be building today. Hit connect to Web3, MetaMask is going to pop up. I'm going to connect to this wallet. Just want to make sure this is the correct wallet. It is. Okay, cool. So this is my session keys demo. What's going to happen here is that I can connect and transfer ERC20 token without signing on each transfer. So this is my, so while I connected with this account, you'll see that it ends in BDFD. This is the account that I'm given by Biconomy. This is my smart account. So the smart account that actually does all of my transactions. This smart account will have like any funds on it, any assets that are needed. In this case, I'm going to be transferring USDC from this account to another account. So I need to make sure that this account is the one that has all of the allocated funds for the transaction. And this account here, like I mentioned, around like the ECDSA module, this is the signer for this smart account. Any transactions that get initiated by this account need to be signed by the EOA listed here. Now, you may be thinking, oh, this doesn't really take away the Web3 kind of like experience there. This is just to give you kind of like, for simplicity's sake, a demo, but you can replace like the Connect wallet with things like social logins using services like Privy, Web3 Auth, Particle Auth, etc. These are all also included in our docs, so you can actually abstract even the wallet itself away completely using those social login type of providers. But for now, first I'm going to hit this create session. So it's creating the session, and this is going to be my one and only time that I actually sign for something we're using MetaMask while I use this dApp. So it's creating the session in the background. I should receive a success message very shortly. I always get very nervous in live demos. I tested this out, so I know. Okay, cool. Yes, it just took a second, but it works. Yay. Cool. So now that I've signed my session, you'll see that I have this other button here that says transfer 1 USDC. So I have some USDC inside of this account already. So before this workshop, I just went on like Uniswap, connected to Polygon Mumbai, and just swapped some like test token Matic for test USDC. But let's take a look at this wallet here. So in my tokens list for this wallet, you'll notice that I have 35.9 USDC, right? I've hard coded this session key to have a specific permission that it can only send funds to this EOA. And I'll go over the code for that in a little bit. But I'm going to hit this transfer one USDC button, and it says transferring USDC to recipient. Now, unlike last time, I have no MetaMask pop-up. I don't have to do a signature. But this is still an on-chain transaction because I'm sending USDC. Cool. You see that the transaction has just happened. I'll click that. Okay, oops. And that I don't think I clicked it in time, but you'll see this is now up to 36. Let me do another one just so I can get that transaction link and show it to you. Transferring another USDC. And again, no MetaMask pop-up, right? Cool. Now I clicked it on time. And you'll see this is an actual transaction that is currently being indexed. Cool. Success. Finished 14 seconds ago. Transferring one USDC from the smart account over to this account here. And now we're up to 37. And like I said, I can keep clicking here. I can keep sending USDC to myself still without signing any transaction. This is a very, very simple use case. From here, I just want to show you like what session keys can actually do for you. So that you can now start thinking about ways to incorporate this in your dApps, like start building things, on your end. Let's take a look at the documentation. So this is on docs.biconomy.io. We're going to go to tutorials and go to session key tutorials. So this full tutorial is actually going to walk you step by step in building exactly what I just showed you. But for now, I just wanted to first focus on the session validation module. So the way that the session keys work is there's two parts to it. First, we have what's called a session key manager. This is provided to you by the SDK. The session key manager is interacting with what's called a session validation module. The session validation module is what sets permissions for a specific session key to be able to do something on your behalf. In the example that I showed you, this is for an ERC20 token transfer. And this is the module, which is just a smart contract that is setting specific permissions for this use case, right? So let's just take a look at this. If you want to like look at like the iSession validation module and like the different imports, this is all available on the Biconomy GitHub, and there's a link to that down here. This is the interface that everything is based on. But essentially, if you want to create your own module, you would import this interface and essentially override two different methods. That is this validate session user op and validate session params. Let's take a look at validate session user op and what it does. So this takes a couple of different arguments. These are not anything that you have to define yourself. These are just arguments that must be provided. The interaction with this contract is also something you don't necessarily have to worry about. When you're using the SDK, all of the interactions with this contract happen under the hood. You just need to write the contract in a way that our SDK can interact with it. So let's take a look at some of the things that you can do here. Some of the stuff that gets passed into this function is like the session key data as well as session key signature. There's a user op hash as well. Let's focus first on just like the session key data itself. So this is information about the session key on like different permissions that can be set for the session itself. The session key is an address. It's just an EOA that is created by the dApp. And I'll show you that when we look at the front end code. Next is a token address. In my case, the token address would have been USDC. Recipient. In my case, I hard-coded the recipient to be this address up here, this EOA. So remember, I was sending USDC specifically to this address. So I set the recipient here to be my address. And then the maximum amount, I hard-coded again to be 1 USDC. you could set whatever maximum amount you want. But if you look at the validation logic that's written here, everything that's written here and here, this is all up to you. This is not required. You can completely skip this part if you would wanted to, but this is where you would set your permissions, your specific business logic. So the business logic in this basic example is essentially saying, okay, let's make sure that the token address is the proper token that has been agreed upon by the session, right? So I specifically only want to transact with the USDC. So that's the token address that I provide here. Now, when somebody initiates a transaction, let's say instead of USDC, they try to transfer Dogecoin or something like that. Because in this token, I specifically said, no, it's only USDC. If the token address that the transaction itself is interacting with does not equal the token that I specified here, then it's the wrong token. This is an invalid transaction. It will not go through. Call value should not be 0, meaning like there should be, some value that is call value if the call value does not equal 0, meaning we only want to send ERC20 tokens. We don't want to send like any ETH or Matic or wherever network you're on. This is just making sure that there's no non-zero value there. Again, this is optional. This is up to you if you want to actually keep it there or not. And then again, additional information here. Here we're just like looking at the call data and looking at the recipient and making sure that the recipient that is specified here is the only recipient that is able to receive this. Also optional. You can completely remove this. This is, again, just depends on your business logic. And then if there's a max amount specified, we just make sure we don't go over that max amount. Then we use ECDSA recover to actually recover the session key from there. The validate session params does essentially the same thing. These two different functions are called in different situations. The validate session user op will be called when you need to validate specific transactions for a session. And validate session params is going to be called if you were to do like a batch session and just need to validate specific params. Like I said, once you've written the smart contract and deployed it, you don't have to worry about interacting with it. The interactions happen automatically through the SDK as long as you provide the SDK with this deployed contract and as long as it is written using this specific interface. If you want to look at specific test cases and like ways that you can make sure that this is written properly, if you look at the session validation modules here in the modules folder. There's also a test folder where you can look at the different tests for the modules. So you can copy this and write your own tests over it to make sure that it works the way that you expect it to work. Now, that is the session validation module itself. Let's go to the code and see how it was used. This is just a Next.js front end. Nothing fancy going on there. It's the little demo that I just showed you. So we're going to be looking at a couple of different components. The index file is just taking care of initializing the Biconomy SDK. So getting an instance of the bundler and paymaster, which you can get from the Biconomy dashboard. So if I'll just show you that Biconomy dashboard really quickly. If you go to dashboard.biconomy.io, you can create You can add a paymaster, create it, add it to all of the different networks that we support here. We're adding more networks as we go along as well. And for bundlers, there's actually just like a single bundler link that we provide for now. You can simply change the chain ID to whatever you need. This link only works for test networks. If you want to deploy on a mainnet, any mainnet, you just have to reach out to us and we'll give you an API key for a mainnet. Cool. So let's now take a look at the front end code. So that's how I'm getting this bundler URL as well as this paymaster URL. And then this is just like a very basic connect to MetaMask, situation here. This can be replaced, like I mentioned, with any other signer. So going back to the docs, if you wanted to replace this, like let's say with social login or something like that, we have a whole section here on signers. We're signer agnostic, so you can use any signer that you want. But like, let's say sign in with the UA. I used Ether.js in this example. You can use VM, you can use WAGMI. And then for like specific social logins, you can use Particle Network, Privy, Magic, DFNS, Web3 Auth, as well as like, even if it's not listed here, the only thing that we need from like a specific social login provider is just that Ether signer object. So as long as you can get the Ether signer object from them, it is fully compatible with Biconomy. And if you look at the description, it shows you here what we mean by that. As long as you provide the signer object to the creation method of the ECDSA ownership module, it is compatible. Cool. So now I've connected to my externally owned account, and using that externally owned account, I created a Biconomy Smart account. You want to make sure that you use the Biconomy Smart account V2. The Biconomy Smart account V2 is the one that is actually compatible with modules that you want to use in this case. This is just a bunch of console logging and setting state that I did. But let's focus now on the two main components. First is creating the session, and then the ERC20 transfer itself. So creating a session is fairly straightforward. It's essentially you're going to be doing a transaction on chain using our session key manager. So you look up, if you look at the Biconomy modules package here, there's two things we import: the session key manager module, as well as the default session key manager module address. So the session key manager module, when we create the session, and you'll recall that I had like a little toast that said it's creating the session. That's what's happening here. There's a couple of things that we provide to the module itself. First, the ERC20 module address. So that's this this smart contract that I went over earlier. Let's see. This smart contract here that I went over is deployed at this address. So I provide that address to this module over here. You can replace this address with whatever you want. If you wrote your own module with your own validation logic, with your own rules, simply replace this address with that address, right? So that's that flexibility of you being able to set your own rules for what your session key can do, right? Next, we have to, on the client dApp side, create a session key. So using Ethers, we create like a random wallet, and that gives us a session key EOA. So this is a separate EOA that will be controlled by the dApp, right? We get the address for the session key EOA, and we are actually saving the address to local storage. We're saving the session's private key. And you may be saying like, holy crap, why are we saving a private key to local storage? This is just for the demo. You can look at different ways of like how you want to manage storing the private key of the session. So just to be clear, when we create the session key EOA, this is not a user controlled wallet. This is a wallet that is controlled by your DApp. But this DApp is going to have specific permissions for signing with for the user smart account, right? Sorry, I'm a little under the weather. So there's a couple trade-offs in like how you can manage this. You could save this to local storage, but there could be some malicious intent of like people who maybe they have some weird Chrome extensions that look at local storage and like pluck the private key and things like that. But if you save it to like a database, you now have like a more centralized solution of like you have full control over like their private keys and things like that. So you have to look at the trade-offs of like how you want to approach this. At the end of the day, because session keys have a limited amount of permissions, my personal belief is that it's kind of okay to put this in local storage, because you'll see later, we actually limit what a session key can do. You can set an expiration date for that session key. So like after a certain amount of time, that session key just becomes useless. You can set like in this validation module for the ERC20 transfer, I'm making it so that this signer can only send a specific amount of USDC to one specific recipient. Even if someone steals that key, they can only do one action with that key, one single action that we defined in the smart contract, right? So you just have to look at the trade-offs, what you're comfortable with. I think this is okay in the case of a session key, but you can look at different ways of storage as you want. So now we're going to create the actual session module. So we take our session key manager module, which has a create functionality. It takes the module address that we defined. It takes a module address, which is actually just the session key manager module address. It takes a smart account address, which is your smart account's address. And then it creates the session key data. So if you recall, inside of the smart contract, we defined a few different things that need to be inputted here: a session key address, a token, recipient, and max amount, right? So these are the things that we need to supply from the front end. 3 addresses and an unsigned integer. So first is a session key EOA. That's the first address. That's the session key that we're giving. Next is the ERC20 token address. This is the ERC20 token address for USDC. Next is the receiver address. This is the EOA that I showed before. So this session key EOA can only send USDC to this specific address at a maximum amount of 50 USDC. So these are the restrictions put on this session key. So even if someone were to steal this session private key, this is the only one single action they can take. They can simply send ERC20 tokens to this address. So as you can see, because of the limitations that we put on this private key, maybe it's not so bad to save it in local storage, right? But again, it depends on your DApp and like what type of permissions you're giving to the session key. Finally, we create the session data itself. For valid until and valid after, I put 0 and 0. If you put 0 and 0, basically there is no expiration on this session key. So don't do this in production. You should give an actual expiration date. This just takes any Unix timestamp. So maybe you want to have it invalid within an hour, within a day, within a week. You just put this timestamp here. You can also set it so that it is not valid until a specific time. So the session key will only be valid between this time and this time. And again, if you put it 0, it's just infinite. So don't do that in production. Session validation module, so the module that we deployed. Again, this is any smart contract that you want to deploy yourself, as long as it is adhering to the standard that we kind of set there. Session public key is just a session key EOA, and then the session key data is what we defined here. So again, like I mentioned, you don't have to interact with the smart contract itself. As long as you provide these details and the details here, it's the session key manager module that will do all of the on-chain interactions for you, as long as you've written the smart contract correctly. So now there's going to be that transaction. So if you recall, there was one transaction I did sign for. This is that specific transaction. So that's being pushed on chain. That gets converted to a user operation. One thing to note here, I did not make the gasless transaction. I do have some Matic on that smart account. So the smart account itself is paying the gas, but you can decide to now make this a gasless transaction, so that even creating the session is, something that the end user doesn't even have to worry about actually taking care of the gas themselves. And I'll refer to some of the documentation on that in a second. But at the end, once this is good to go, you'll get like a little toast of success. Otherwise, you'll get a little error pop up over here. So that is for creating the actual session. And then next is utilizing that session to do a ERC20 token transfer. So here, this is just that initial toast for sending 1 USDC to the recipient. I hard coded this to 1 USDC. The max amount that we set is 50. So if you wanted to replace the button with an input for numbers and let the end user give an input themselves, you can do that. For simplicity's sake, I just made it a button. But that's completely up to you and how you want to do that. So now, again, we're just specifying that the address of our module, in this case, it's the ERC20 module, which is deployed at this address. Now, from the local storage, we're getting the session private key and creating a instance of that so that this session key can actually sign for the transactions. So this is basically making it so that you don't have to sign with your MetaMask pop-up. The dApp is signing with the session key instead of you signing yourself. We create the session module here, and then we activate the module on our smart account. Once it's activated, we then just do a simple, this is just like an instance of the contract. I'm using ethers to connect to the Polygon Mumbai USDC address, providing it the ABI as well as the provider. I first set the decimals to 18 because that's traditionally how many it is. But for USDC, it's weird. It's a different amount of decimals. So I just go in and update the decimals based on the contract. So you may use different contracts with different decimals. Instead of hard coding it, I just fetch it from the token contract itself and update it. And then finally, we do the transfer itself. We use the populate transaction to create a raw signed transaction where we're saying that we're going to send USDC to a specific receiver and we're going to send them 1 USDC. If I changed this address to something else, this transaction will not work, because when we created the session key, we specified that it's only this address that can receive USDC. So that's just a limitation that I placed specifically for this workshop. It's just to show you some of the different permissions that you can do. So let's actually try this out. I'm going to take a different receiver, a different address. So now there's a different address here, right? So this is a different address than the one that I specified in my ERC20 token address. So I'm going to expect that this is going to fail. So let's go back to the session key manage module, transfer 1 USDC. So it's transferring USDC to the recipient. That is not what I wanted to do. Let's go into the console, and it should send out an error. Did that error already happen? Yeah, here it is. So AA23 reverted, wrong recipient, right? Because our session validation module specified there was only one recipient, but because we changed the recipient in the actual transaction, it doesn't work. So everything is like very rigidly determined in that smart contract. So if I switch it back to the address, it will then actually work. Cool. So this is just the actual transaction itself and building out the user operation with the proper params that we need for the session, and then finally sending the user operation. If you wanted to make this a gasless transaction, you would edit these fields to make that gasless. And this is the transferring of the 1 USDC button. So this was kind of like a very basic overview of what you can do with sessions. I tried to keep it as simple as I could. For the actual bounties, if you want to be eligible for it, we're expecting definitely a lot more of a robust use case. Some of the use cases that would be cool, some of the things that you could build here, things like payment subscriptions, right? Imagine now, like you want to have a session key that has permission to pull a certain amount of funds on maybe a monthly basis, maybe a weekly basis. Now you have a session, a way to create a subscription module for different folks who are providing services, right? You can even just take the ERC20 validation module that we gave you and edit it to be able to transfer a certain amount of tokens on a monthly basis. You can do things like automated token trading, building a module that trades tokens based on different conditions, gas prices, token prices. Look at different oracles that gives you some of this information. Create ways to automate the token trading aspects of it. Imagine creating like an AI that is able to control the session key that you create on your dApp, and the AI is then able to transact on chain on behalf of your user. Doing things like daily limits, create modules that dictate on a daily, weekly, monthly spending limits for an end user. Some more ideas. NFT rentals. We looked at ERC20 session validation module. You can update that to be an ERC 721. Create a module that allows P2P NFT rentals between users. Obviously there are standards around NFT rentals, but what if you can just take a regular 721, create a module that allows for rentals between users based on a session? I mentioned before, gaming is a really cool use case as well. Signing transactions for on-chain gaming sucks. How can you use session keys to improve gaming use cases? Build a cool like on-chain game that utilizes these session keys in some way. Another really cool one, an idea that I've seen floating around, is creating like a wallet burner factory. Allow users to create burner accounts for specific transactions. Create like an account with a session key that allows you to do one specific thing, and then it just burns that session key after that specific action is taken. So it's a really cool way to just like test out, try like different secure methods of trying different transactions on chain without having to expose like your full smart account to those issues. So we're really hoping that you're excited that you build some really amazing use cases. Again, we're not looking for basic use cases. We're looking for real things that could make an impact things that could become a product, things that you can use to build maybe on-chain games, things that are really fun to play. As you're building this out, let us know your progress. You can add us at Biconomy. You can at me at Rahat Codes on Twitter. And yeah, thank you. Happy to take some time as well to answer any questions that folks may have.
Thank you, Rahat. So it's going to be question and answer round. If anybody is having any questions, please free to ask to Rahat. He's here to help you around. Also, you can drop your questions. Also, we are available on Discord for any time you need assistance, any help. So yeah, you can go for it. So please drop your questions. We will wait for 2 seconds if there is any questions. Otherwise, we can end this session. So guys, come on. Is there anything you are having confusion with or any look around? Please ask. Please put your questions. So yeah, so I think that's it. So first of all, it's a very great session, and we are very thankful to Rahat for sharing such amazing knowledge with us. Also, guys, you guys already know that there is a bounty, also a sponsored trip to India, and I think guys are coming. Um, I think Rahat is not coming this time, so we will miss you for sure. So
Yeah,
yeah,
a little bit sad about not coming, but hopefully next year.
buckle up, guys. Show activeness in the sessions and grab your opportunity to fully sponsored trip to India. And by ending this session, I would like to thank you all for being such an amazing audience and celebrating this success of this session together. So yeah, thank you everyone for joining, for learning, for exploring. So yeah,
Thank you, everyone.
okay. Thank you guys.
Bye.